Let's explore inequalities. Why? Because in mathematics, sometimes the answer is not just one number. Sometimes it's a whole range of possibilities. Stay tuned. Mathematics isn't just about numbers. It's also about understanding relationships, and solving inequalities is a key part of that. In this lesson, you will learn how to represent inequalities on a number line and also visualize the solutions. With that being said, let's take a look at what is meant by the term inequalities. So, what are inequalities? Inequalities are the mathematical expressions in which both sides are not equal. Very important to note that. We're accustomed to doing equality where we say solve this equation and we get one value. So we know both sides are equal. But in the inequality, both sides are not equal. Now, inequality, unlike in equations, we compare two values. So they're not equal, rather we are doing a comparison between them. So therefore, the equal sign between two values is replaced by less than or equal to sign, or it could be greater than or equal to sign. So less than, or it could be less than or exactly equal to, greater than or greater than and exactly equal to, but not the equal sign. Very important note there. Now, what is the difference between the inequality and the equality? The difference has to do with the solutions. So, in an equality, the equality has just one solution. So let's have a look at that example. So if I say 2x is equal to 10, there is only one possibility of a number. When I multiply that by 2, the answer is 10. So therefore, in this one, x is exactly 5 and no other possibilities. However, let's have a look at the inequality. The inequality, on the other hand, has a range of possibilities for the solution. So if I take this example, if I say x is greater than 5, there are a range of possibility. Now 5 would not be a solution because x is greater than 5. So we would start with our first solution to be 6, but we can go on from 6 to infinity. 7 is also greater. 8, 9, 10, and that it goes to infinity, hence a range of possibilities. So we use inequalities when we have a range of possibilities rather than just one solution. Okay, now when we're navigating inequalities, it's important to know the symbols that we use and how to read them correctly. So my first symbol here means less than. Now, how do I know when I have a less than? So let me just do that numerically. If I say x is less than 5, I can read this because I know the open mouth of the arrow is always turned to the greater value. So because the open mouth is turned to 5, then x is less than 5. Now the other symbol is the opposite of this one. Notice here that there is no line under it. So I could write that x greater than 6. The open mouth will now have to turn to x because x is greater than 6. So the other symbols are similar, except that in the first two, 5 and 6 are not possible solutions for those inequalities. However, if I change the context here to mean less than or equal to, so I'm going to use the first one, x, and then put a line under, so x is less than or equal to 5. This then means that 5 could also be a part of the solution. So we start at 5, and then every value that's less than 5 going on to negative infinity would be a part of this solution. Now we're going to do x is greater than or exactly equal to 6. This means that 6 would also be a part of the solution. So every value from 6 going on to positive infinity would also be a part of this solution. Now, pause the video, write the symbols down, and make sure you understand what each of them mean. This is going to be critical to putting our inequalities on our number line. Okay. So now we're going to look at how do we represent inequalities on a number line. So you will often be asked to represent inequalities on number lines. To do this, we are going to be using circles. We always use circles to tell the start and the end point, and also a line that represents the range of possible values to show the solutions on the number line. Now, in order to do that, we have to be able to distinguish and learn the different symbols we use for our key. So first one, if we have a circle that's unshaded, this means the value is not included in the solution. So an example here, if we say x is greater than 4, then 4 is not a part of the solution. So on my number line, I will know this with a circle that's not shaded in. Now, if my value is included, then I will have a solid circle. An example of that, x is greater than or equal to 4. This means that 4 is also a part of my solution. Again, we have to make sure that we know the key. Now, when we get to graphs, which will be the next lesson after this one, you will now learn what is equivalent to these circles on the number line and on the graph. Okay. So we're going to practice our first example of putting an inequality on the graph. So important point here, when we represent or plot inequalities, we must show whether they include or exclude the starting number. So we're given here that x is greater than or exactly equal to 2. So remember, we discussed the different symbols. We can see here in this inequality, there is a line under the symbol. This means that 2 is a part of the solution. So how we read this? X is greater than or equal to 2. Now, once we have established that, we focus on our symbols. Is it a solid circle or is it an unshaded circle? So let's go. Now we've got our key here. So we know solid circle includes and the other circle without shading in excludes. So I've put my solution here. I need to put a circle at 2. But because 2 is also a part of the solution, it has to be a solid circle. And because the values go on to the positive infinity, I now use an arrow to show that all numbers from 2 to infinity is a part of this solution. So greater than or equal to 2 means 2 can be a possible answer, and everything above 2 which goes on to infinity. And that's how simple it is when we are only given one endpoint. So let's do some more examples. So in example 2, we are told x is less than 3. So I put that in, x is less than 3. Now I need to think, solid, shaded circle or unshaded circle. Now there is no line under my symbol, so that means I will need an unshaded circle at 3. So I go ahead, put my circle at 3, but it's less than, so my direction matters. If it's less than, it's going to go to the left. So we just simply need to put an arrow projected towards the left, and this is us representing that inequality. Beautiful. Okay, context is now changing, because now, if you notice in this example, we have 2 endpoints. Same principle apply. Now we start reading our inequality from the middle. So we read from x. If we read along here with -3, we will notice that the open mouth is pointed towards x. This means that x is greater than or equal to -3. If we read the other number on the right hand side, we can see the open mouth is turned away from x. Therefore, x is less than 5. So we reason before we start drawing our endpoints. Which one of my circles will be solid and which one will be unshaded? So first of all, I can see there is a line under the inequality closest to -3, so that one would be a shaded circle, while on the right hand side that circle will be unshaded. So now I will just put my boundaries in. So 2 boundaries there, so x is greater or equal to -3, greater than or equal to -3, but it has to be smaller than 5. Once I identify that, shade my circle in for the -3, not shaded for the 5. I just need to use a line to connect them. They must be connected by this line. Now, this is my range of values. So, I look on my graph, I can see -3 is a part of my solution. So if I should be asked to write down these solutions, they would be -3, -2, -1, 0, 1, 2, 3, 4. But 5 would not be a part of that solution. Amazing. Okay, so let's go on. I'm just going to now talk you through questions you need to ask yourself when you have gotten question of inequality to do. So here we're asked to show x less than or equal to 7 on a number line. So my thinking, first thing I'm asking myself, which number do I start at on the number line? And the answer is 7. So the next question is x greater or less than 7? Here we can see that x is less than or exactly equal to 7. Once I've thought that through, the next thing I need to think about is which circle do I use, a shaded or an unshaded circle? We know that we're going to use a shaded circle because there is a line underneath the inequality given. So we go over to 7. So next question is which direction? So we're going to go to the number line, we're going to draw a circle. We know it's a solid shade, so we're going to shade that in. And then we're going to ask ourselves now, which direction should I go? So x is less than or exactly equal. So all the numbers to the left here is less than. So therefore, that's how I put that on my number line. Brilliant. So again, I cannot stress enough on talking to yourself, asking questions in a clear and logical way. And that helps you to be accurate in your solution. All right, so we're going to move to your turn. Let's see if you understood up to this point all of what I've said. So what inequality does this diagram represent? So pause the video and see if you could write this down. Okay, I hope that you have said A. Clearly, unshaded circle. So that means 2 is not a part of the solution, and the arrow goes to the right. That means the values there are greater than. So x is greater than 2. Brilliant. Here is another example. Pause the video again. Have a go. Okay. I hope that you've managed to say x is less than 4. unshaded circle over 4 going towards the left. Therefore, x is less than 4. Beautiful. I know that you got this one. Okay, so final one that you'll practice on this here. Pause the video again and have a go. Okay, I noticed that this time I've got a solid circle projected towards the right, which means 3 is a part of the solution and beyond 3 to the positive infinity. So you should have said b. So b is greater than or equal to 3. Awesome. You can see here, once you know how to read your inequalities, if you're given the graph, you should be also able to write the inequality that satisfies that number line. Okay, so now we're going to look at where we have 2 endpoints and just talk about your thinking. So similarly to what we've done before in the first thinking question, we'll do the same here. So this time we ask ourselves, which 2 numbers are the boundaries? We can see here we've got 5 and we've got 7. Awesome. So the next question is, which circle does each of them use? So let's just put them on the number line first. So I've got circle here and one at 7. Now, line under 7, so I know solid circle. We put that in. Now these ones are pretty easy in terms of the arrow or the line, because clearly if it's between 2 points, the 2 points are going to connect. So you don't have to worry about is it left, is it right for these ones. Now 5 doesn't have a line under, so therefore I just need to connect them. And now I have represented my answer on my number line. So what are the solutions? Is 5 a part of the solution? Absolutely not. So if I should ask to write what are the solutions here, it will be 6 and 7, and that's because 7 is shaded, so then it's a part of the solution, while 5 isn't shaded, but between them is also 6. So my solutions are 6 and 7. Brilliant. Okay, now it's your turn. 2 endpoints. Now, what inequality does this diagram represent? I'm going to give you some options, but think about it just a bit before I show the options. Okay, so option 1 is x is greater than 1 but less than 4. Then I've got B, x is greater than or equal to 1 but less than 4. And C, x is greater than or equal to 1 and also greater than or equal to 4. I hope you've said the first one, because you can see here 1 and 4 are not a part of the solution, 2 unshaded circle. So if I should write my solutions down for this one, the answer would just be 2 and 3 that fits the criteria, since 1 is not an option, 4 is not an option, so 2 and 3 would be the only 2 solutions for that graph. Sorry, that number line. Okay, now what inequality does this one represent? I'll just show you the options and see if you would have been able to select the correct one. So a good practice here is to write your 2 endpoints down, then decide which one of them should be shaded and which should be unshaded. Then look at your directions. -3 going to the right, so that means everything including -3 greater than, and 4 going to the left, not shaded, so not a part of the solution. So your answer should then have been B. So write them down first and then look to see which one of them fits the criteria. Great. So now we're going to move on to where we have to solve an equation first, or an inequality first, before we can put it on the number line. Now, if you know how to solve an equality, then it's similar for the inequality. So I've got here x plus 4 greater than 10. What I need to do here is to make x the subject of this inequality. So I need to subtract 4 from both sides. So I've got here left on this side, x is greater than 6. Now that I've done that, we've talked through the thinking process already. So just to remind you, what number do I start with? I've got to start with 6. So I go to my number line and I put a circle at 6. I'm not going to shade it yet because I don't know if it should be shaded, because I need to now check again what I've got before making a conclusion. So, is x greater or less than 7? X is greater. This should be 6 here, so it's greater than 6. So is x greater or less than 6? We can see it's greater. So that influences now my direction. So we go, which circle do I use? Unshaded, there is no line under the inequality. And direction, if x is greater, I know I'm going to the right. So therefore, I need to turn right here. So there we go. Thinking, and then we do the inking. Brilliant. So what are the solutions? Here now is where we've got 7 as our first answer, since 6 is not, so it's go from 7 to infinity. So if I'm working on this number line particularly, then the answer would just be 6, not 6, 7, 8, 9, 10, and 11. However, if we were just asked an open-ended question, not specific to this particular number line, then it would be from 7 to infinity. That's the answer to this question. So it's just 7, 8, 9, 10, and 11 using this particular number line, since 6 is not an option. Beautiful. Okay, so another one where we have a variable on both sides. So we're going to write our equation down. Plus 4, I think I said equation, it's inequality. So plus 4. Okay, so we're going to solve it and then apply the thinking. So we can see here we have a variable on both sides. So therefore, what we need to do is to collect our like terms. So I'm going to put my 4x here and my 4 there, so that the constants are together and the variable terms are together. So remember, I'm going to have to subtract 4x, so 6x take away 4x will be greater than positive 10 is left, and we're bringing positive 4, so it's going to be minus 4. So 6x take away 4x gives me 2x, so 2x is greater than 10 take away 4 is 6. I now need to divide by 2. So then x is greater than 3. Awesome. Now what I would do at this point, if I was a student, I would have talked myself through the thinking process. So we know, first of all, we're going to need to determine where on the number line do we start from. And we know we have to start at 3. So I'm just going to extend this here and just put the number 3. This number line starts at 4, but we can just extend it and put our 3 there. Okay, so once we've done that, we need to decide, is x greater or less than the number that we've got? And x is greater, and that propels us to say, what direction do we go? So circle we know is unshaded, so it's going to be an unshaded circle, and direction will be to the right, and that's because x is greater. So I'm just going to go and make my arrow projected along, showing that I continue from 3, not inclusive, to infinity on my positive side of the number line. So again, if I'm asked to write the solution from this specific graph, 3 is not considered, but my answer would be 4, 5, 6, 7, 8, 9, 10, and 11. Now remember, these solutions are specific to this number line. If it was an open question, then any number from 4 to positive infinity would then be a part of the solution. Awesome. So we now learn how to put the solution on a number line. We also know how to read the inequality from the number line and also to write down the solutions from the number line. Amazing. So let's look at some exam questions. In this question is 3 marks. Now you can see here, first one, we're given the number line and we're also given some suggestions. Then we're given the number line, but we're not given, so that's a progression, no suggestions. We're going to approach both questions the same way. So what I would always encourage you to do, forget about the solutions that were given as an option and write down your own and then see, can I find that there? That's how you know that you are correct. Okay, so I know my boundaries. We're asked to circle the inequality shown by the diagram. So I look on my diagram. First of all, I'm going to write down my 2 endpoints. So I'm going to write 2 and 6. Now, we know our variable is always in the middle. So I'm going to go ahead and I'm going to put x in the middle. We go back to the number line and we look. From 2, first of all, we can see that circle is unshaded. So we know as well there will be no line under that inequality. We go to 6, we see that one is shaded. Therefore, there will be a line underneath that inequality. So now it's about direction. If we look here, going to the right, we can see x is greater than 2. So we go to x, we have an open mouth turned towards x. X is greater than 2. Now, when we go to 6, we can see we're going to the left. That means x is less than 6, so arrow turns away from x. However, 6 is also a part of the solution, so line under that inequality, and then we check again. So x has to be greater than 2. From 2, it's going to the right, that line. Check, x is less than or equal to positive 6. From 6, we're going to the left. So we know we've gotten our answer correct. All we need to do now is to look for the inequality in the options. That's a part of this, that's the solution. So I can see here, this one, the third one, fits that criteria, but check it carefully because these signs can be very confusing. So x in the middle, open mouth turns towards x, no line under for 2. Then open mouth turns towards 6, line under. So we know definitely, see? That's my solution. Okay, so now we're asked to write down the integer values this time that's satisfied by the diagram that's shown. So first of all, I know my end points, positive 1 and positive 7. Now I need to observe, is 1 a part of my solution? And the answer is yes, because it's solid shaded in. So I'll put that on my number line. 1, 2, 3, 4, 5, 6. Stop. Question. Is 7 a part of my solution? It's unshaded, so the answer is no. So the integers that satisfy this is 1, 2, 6, and that's 2 marks. Usually, if you forgot one of them or if you include one that should not be included, you would have only scored 1 mark rather than 2. You have to be dead on accurate for this. All you have to do, take your time and check again to see that you've included what should be included and also excluding what should be excluded. So here you go. Here are some questions. You've got some number lines. You need to write the solutions down for these, and then you need to solve those inequalities and then put them on the number line. Now, this is what you should have for your solutions. I hope that you managed to get them all. And if not, all you have to do, just go back and play the video another time until you manage to get it. Okay, so now we have reached a very important part where we talk about our key takeaways. What are you taking away from today's lesson? So, First of all, we talked about what are inequalities. We did say they are mathematical expressions in which both sides are not equal. Also spoke about the fact that we use, instead of an equal sign, we use the inequality symbol, such as less than, greater than, less than or equal to, greater than or equal to. We talked about the fact that we have to use a particular key in order for us to put our solutions on the number line. So an unshaded circle means the value is not included in our solution, but a solid circle means the value is included. Okay, we also looked at the difference between an equation and an inequation, or we could say an equality and an inequality. So the equality has just one solution, while the inequality has a range of values. Awesome! I am so proud of you. Now, before you go, I just want to remind you, if you haven't yet done so, hit that subscribe button, share, hit the notification bell as well, so that you can know when another video is uploaded. Remember, also on TikTok, we do extra exam questions that we haven't explored within the lesson. Thank you so much for watching.